Okay, hello everybody. Thank you so much for joining us for one of our breakout sessions during this week's virtual college fair for CUSD. You're here with us today to participate in our engineering, preparing for an engineering program panel with our expert admissions reps from all over the country. My name is Bea. I'm with CUSD-Futureology. I'll be moderating today's presentation. Just to let you know, this presentation will be recorded and it will be posted on our website by next week. If you do have questions, make sure to use the Q&A function at the bottom of your screen to ask your questions, and we'll make sure to devote some time at the end of today's presentation to answer your questions. And just to let you know, your microphone and your camera are turned off, so you don't have to worry about that. You're just here to soak it all in and enjoy the information and the presentation. And with that, I'm going to pass it off to Will, who will be running the rest of the presentation with his cohort.
Awesome. Yes. Thank you so much for being here, everyone. We just want to introduce ourselves really quickly to you, and then we're going to jump right in. My name's Will. I'm with the Illinois Institute of Technology and admissions counselor, obviously, at the Illinois Tech.
Hi,
Pam, do you want to go ahead?
Hi, I am Pam. I am with the University of Florida. I am West Coast Regional Admissions Officer based out of the southwest corner of Colorado.
Hi, my name's Evan Lorenz. I'm an admissions counselor with the University of Illinois Urbana-Champaign. I'm actually filling in for a colleague right now, James Gilby, who is traditionally the admissions counselor for your area. So I'm stationed in Illinois and work with Illinois students, but I'm very excited to work with you all today as well.
Awesome. Well, Pam is going to kick us off here, so I'll go ahead and let her start.
Welcome. Thanks for joining us tonight. We're going to touch on STEM. So what is STEM? You're here, you're learning. What is STEM? STEM is a curriculum based on basically 4 different areas: technology, engineering, and mathematics. So we'll talk a little bit about STEM. Why is it important? How is STEM in college different than high school? The careers. So sit tight. We'll cover everything, and we'll give you a chance to ask some questions at the end in the chat. So why is STEM important? Okay, STEM, I mean, we depend on STEM. Our whole world depends on STEM. Think about recently COVID. Those are all STEM people working to try to make a cure, work on the masks, work how we social distance. So STEM is happening daily around you, all different places. Our economy depends on it. It's innovative. It's people are going to influence. You have to be creative. You have to be able to think outside the box a little bit. It seeks truth and proof. Anything that uses science, you're going to back everything up with science. So if you're one of those people that like to prove things, then STEM may be really great for you. It's always changing. Last year, if we gave this presentation and the different majors and the things that are innovative and in the news, it's going to be different than what it is this year. So it's always evolving, something new, something exciting. And it's many, many doors. So if you're studying STEM in college, this is the way of the future. This is our technology. Studying STEM, you're going to have great work aspects when you get out of school.
All right, so I'm going to pick up on this slide. So let's talk a little bit about what STEM looks like in college and versus high school, because there are some major changes, and I think it's important that we kind of take those into consideration when we're looking at STEM. So the first thing is that you're going to see that most of that content you're getting in the first year or two are going to be taught in large lecture settings. And so when we talk large lecture, that can be upwards of a couple hundred students. So that's something you need to keep in mind. And with these larger lectures, some of those courses might be taught by those grad students, those TAs. You might not have your course being taught directly by your professor. So that's really important to keep in mind. Once again, that's in those first couple years. And going along with that, you'll find that lecture, class doesn't meet 5 times a week. It's probably going to meet closer to 3 times a week in that large lecture setting with, maybe 200, 300 students. And then you're going to find you're going to have a lab added onto that, which meets outside. So you might have a Monday lecture, Wednesday lecture, Friday lecture, and then a Friday lab, where it's probably going to be a smaller atmosphere, and you're going to find it's a lot more intensive for yourself. And it's probably going to be a little bit more hands-on experiences, a little bit more participation. Another important thing to look at is you're probably going to need to adjust your study habits. Sometimes your professors might ask you to come in with knowledge already prepared. You know, typically in high school, it's we learn a lesson, you get assigned a homework, you do the homework, you come in the next day, we go over the next topic. Where in college, they might say, I want you to read these couple chapters, and then we're just going to hop into that material. And so that can be quite different. So you're going to need to take time outside of even just doing the homework to make sure you're reading what you need to read so you're prepared for that next lecture. And then other things to think about are research opportunities. So within STEM, you can start in college, you can start doing research. And so what kind of opportunities are going to be available at the universities you're looking at? How can you get involved? Is that talking to your academic advisor, talking to your professor, maybe working with that academic college or unit? What does that look like? And then lastly, internships and co-ops, kind of understanding why those are important and what those outcomes mean. Doing those internships, you're able to get great professional resume experience. And with those outcomes, you'll find that, you know, if you intern for an automotive industry company, that'll really serve you a lot of return when you're looking into those next steps post-graduation. So always look at what's available for internships and co-ops.
Absolutely. And one of the things that's really great about a STEM career is that it can have a lot of different pathways. You know, as Pam mentioned, STEM is changing every single day. So what you might enter, you know, as a early person in your career might look very different than where you find yourself 5 or 10 years down the road. The field you know that you end up working in may not exist today, and that is one of the things that's really great. One of the things that you will also find in a lot of STEM careers is it's preparing you for all of this, the problem solving, the being comfortable, you know, learning hard concepts and challenging yourself. Those are things that are going to serve you not just in, you know, your 4 years at an institution, but really in your entire career growth. It's really going to prepare you to think about, how do I, you know, make an impact, and how do I prepare myself for all that might lead ahead. So looking at a career in STEM potentially means looking at a lot of different pathways. Next up, we're going to talk with you about a few different types of engineering and what that encompasses. So each of us are going to mention some pathways, some sort of what each of these engineering fields are. So I'm going to kick us off with the architectural engineering. This is definitely something that my university definitely has a strong impact in. Architectural engineering is different from architecture in that it's really all about the structures of buildings. Is it a space that's going to work from a structures perspective? You can design the coolest looking building, but if it's just going to fall down as soon as it's built, that's not what we want. And so obviously architectural engineers work alongside architects. They are the folks who are making sure that these structures are going to, you know, have a nice long impact and be around for years to come. They also help make spaces more usable for folks. If you think about how much time you spend inside of buildings, especially now, as much time as we're spending inside, you know, having spaces that are, you know, conducive to life is definitely positive. But thinking about how, you know, classrooms are designed from a noise perspective. On our campus, we actually just opened a new building a few months back. And one of the things that they put inside this building was like a noise dampening system for the entire building, because it's one giant open space. But the walls are basically inflated, so you hear like pumps running all day, so it dampens the noise a bit. And that was something our architectural engineer came up with. It's another great area if you're thinking about sustainability. Think about what goes into designing buildings and all of the materials that are used. So if you want to make an impact and help, you know, us reduce our environmental impact, architectural engineering could be a great pathway to do that. Definitely one that you're going to have licensing. It's very important to make sure that these buildings work and that the things that you're involved in are going to actually stand. And so it's definitely a field where you have to think about those professional licensing requirements. That may mean you have to go to an ABET accredited program. That may mean, you know, thinking about the classes that you're taking, being prepared for those professional licensing exams. And that's something that you'll find a lot of our programs are going to prepare you for, because we want you to be out there. We want you to be working. We don't want you to just get the education, which is great, and we want you to have that. But we also want you to be great alumni representing our universities. Connected in some ways to architectural engineering is civil. So it's a little different, obviously. It's not quite as building focused as you might expect. This is more of those big public works types of projects. So roads, bridges, airports, which obviously include buildings for the most part, but the actual runways and things like that as well. Thinking about the sewage systems, which not exciting to think about most days probably, but for some people it is, as well as the structural engineering components. So the thing that I think is really cool about civil engineering is how many niche specializations there are within this field. If living in California, maybe you're really interested in seismic, designing things with earthquakes in mind, which obviously we need. Maybe if you're in a different region, it's more thinking about hurricanes and how we're making sure that buildings can withstand that type of an impact. So thinking about all of those niche areas within these types of fields may get you really excited about the pathways that lie ahead. Another thing that civil engineers, and I know this from the students that I talk to who are in this specific major love, is that it's not a desk job. You are not necessarily going to be spending hours upon hours just sitting at a computer typing. You actually get out into the community. You actually see the spaces that are being constructed. They're on site a lot of the time, making sure that things are going up. And that's important because for that same reason that we talked about with the architectural engineers, we need a licensed person on site to make sure that this is actually going up the way that you wanted it to. Nobody wants an overpass put up the wrong way. And so having a licensed engineer on site is something that is definitely important. You can also see some salary information for both of them. Obviously pretty good salaries in these fields. And I think that's something that you'll see in a lot of engineering. And one of the reasons some students may be interested, but hopefully not the only reason, because it's a lot of work. So you have to really love this field in order to get through it. Next up, Pam is going to talk to you about some not structural types of engineering.
Thanks, Will. I'm going to talk about two different, biological and biomedical engineering. We usually get a lot of questions of these from students at our table, like, what's the difference? Well, you guys are all in school, you all have had science, bio means life. So both of these are going to go around life. So biological, okay, so they do things like agricultural robots, remote sensing, bioprocessing. This has to do with like the world around us, not just humans itself, but how we interact with the world. All the different things about food and our health and energy. All this stuff is about the humans and how they work in our environment. So you're going to educate in biological environment science as well as engineering. So you're going to do a little bit of both in there. You're going to get those all in there. Critical problems involving land and water, biological systems, production, agriculture, and innovations in packaging. And that's unique. Most people don't even think about packaging, like packaging for food, packaging for different medicines. A lot of people that do biological engineering will work in how the pharmaceuticals package their drugs, which is a really big industry in the United States. Thinking about that. Land and water. You're in Southern California. Water is an issue all the time. So a biological engineer, they're going to work on tackling those kind of problems. Opportunities in the agricultural industry, biotechnology, water quality, water resources. You can see there's a lot of great options for you to do in biological engineering. And then biomedical engineering is just a little bit different. So this is, you're going to use engineering to analyze and solve problems in biology and medicine to enhance medical care. So this is specifically for people. What are we going to do just for people? Design instruments, software, you're bringing knowledge out. And I think everybody is very well aware at this point in time, since March, about how much biomedical engineering does really affect our lifestyles and how it plays a strong impact. So if you're looking around at all the stuff that's going on and it's really intriguing to you, then this may be some field you're looking for. So you integrate science and engineering. So you study biology, medicine, behavior, or health. So there's a whole bunch of things. So it's sort of like you're not becoming a doctor, you're more like studying the science behind how everything comes together. Job markets and biomedical engineering is the fastest growing of all engineering disciplines. So that's pretty cool. So when Will was talking about how things change all the time and your job may not be the same when you get hired to even a year or 5 years down the line, if you want that kind of variety in your life, biomedical engineering might be something really popular for you to take a look at. the nation, we need the engineers, and without knowledge of biomedicine, including a cadre of exceptional people whose education thoroughly immerses them in engineering and biomedicine. So this is just a statement that's been put out by a couple of universities just to show how important it is that we have students that are studying biomedical engineering. Evan, you're up.
Thank you. Okay, so, I got to move our cameras. I'm over my talking points. There we go. So I'm going to talk about a couple programs that are really popular at the University of Illinois at Urbana-Champaign. First one I'm going to talk about here is mechanical engineering. So you'll find that when you're a mechanical engineering student, you're going to have a lot of coursework that's focused on circuitry, fluid dynamics, heat transfer, mechanical design, going in a little bit more what that means. So that mechanical design, that's drafting, basically taking everyday objects that we take for granted apart on your computer essentially, and looking what that means. For example, a very popular one is those bike lights that go on your bike at night so that people can see you. Taking those apart on your computer to basically see how those parts all work together for that part to operate correctly. So at the University of Illinois specifically, and I'm sure at a lot of other institutions, you're going to have experiences to work with corporate sponsors for your senior year capstone project. For example, I know a group of students at Illinois, they worked with Ford and looked at their engines to basically design the most volume versus weight efficient fuel tank that they could for the vehicle. So that's something that they worked on. So with that, as I kind of mentioned, you'll find some career outcomes in fields such as the automotive industry, manufacturing, and within manufacturing, that's going to be that product development. So basically making sure you're making the best product and that it's coming out the same every single time. And then also research and development. So if you're looking into creating new things. For students, while you're on university campuses or just looking into the future, there's going to be opportunities to do research in fluid mechanics, applied physics, thermo and heat transfer, as well as getting back into that manufacturing. You'll find manufacturing is going to be a heavy theme in that mechanical engineering field. And as Will kind of mentioned a little bit earlier, nice starting salaries. The average starting salary for mechanical engineering is right around $65,000, so not too bad out of the gate. So we'll switch on to the next one now, which is electrical engineering. Oh, got to move us again. So with electrical engineering, you're going to find this is going to be a little bit different. You're going to have coursework focused on circuits, electromagnetics, semiconductor devices, and computer engineering. I think the best way to kind of, when you think of an electrical engineering student, is they carry around these kits, especially at the University of Illinois, and basically they have wires, circuits, and batteries in them, and they'll frequently be assigned projects where they are creating circuits and literally hands-on experience. Their homework is hands-on experience. I want you to build a little robot car that does these 3 functions. And so it's those really awesome experiences that you get to sit down and tinker and really push your imagination and your knowledge. With that, at Illinois, they have a senior design project lab, which I think is really awesome to always talk about, where instead of working for a company, basically they decide that they're going to do some research and run a lab on it. And then they kind of apply that scientific method of designing, analyzing the data they're getting, looking at the construction of the lab, working as a team, and then kind of reporting that data and what significance they think they found from that. So lots of great experiences to collaborate with, hands-on experiences in electrical engineering. With that, you'll find that there's going to be career outcomes in fields like robotics, networking and information security, wireless networks, and electromagnetics. So I think a lot of that is self-explanatory there. And then once again, if you want to do research specifically at Illinois, we offer these opportunities, but I'm sure they are out there to do beyond that. But research in nanotechnology, looking at programming, looking at human-computer interaction. And then you'll also find that this program has a nice starting salary as well, typically around $70,000 for students graduating with that bachelor's. Okay, so that's a little bit about those majors we decided to talk about. So we're going to talk kind of now, how can we best prepare ourselves for the STEM field when we're making that transition into college? So I think the first thing you can do right now as students is challenge yourself in STEM and humanities courses. Make sure that we are pushing ourselves, if we have AP calculus available and physics and stuff like that, that we're really making sure we're flexing those STEM muscles to make sure they're nice and strong when we get onto college campuses. Making sure, once again, in that STEM focus, that we're taking at least up to pre-calculus. You'll find that in these STEM fields, you're going to have to take Calc 1, Calc 2, Calc 3, maybe even an upper level math course higher than that. So having a proficiency in math there is really going to help. And as we kind of talked about in our slides, some lab science. You're going to have plenty of lab time in these programs. And so having that experience, knowing your way around the technology and the devices you're working with, so you're proficient there. And then another great point is just making sure we're getting involved in those extracurricular and enrichment opportunities. Whether the colleges you're looking at use that as a criteria for their admissions process, or even better, just something to help expand your views and get different experiences under your hands, looking at those math clubs, those science Olympiad opportunities, robotics clubs, any summer programs available at local community colleges or four-year universities, maybe work experience or internship experience. Those are all going to be great things that will really help develop your own skill set and open up your love for these programs, as well as help develop a deeper interest in them. And then lastly, just make sure you're talking to your friends and family who work in the STEM fields. Ask them questions. Make sure that what you're thinking really is that path that you want. Or maybe discover a love for some new type of STEM that you weren't originally interested in. Keep your mind open.
And on that note, we're actually going to share some resources with you. So in the chat, I am clicking send right now. So I encourage you to grab this link really quick before the session ends. But basically, this is just a big resource sheet, not a huge resource sheet. It's a resource sheet with some places where you can learn more about some of the things that we talked about today. A few of the ones that really jump out at me and that I think are a really great resource is the IEE trying their Try Engineering. It's a whole site dedicated to electrical engineering. So you can learn about some of those things Evan mentioned. Take a chance to kind of see, is this a field that I might want to do? And all of these are great virtual resources. So you can do these safely from home. You don't have to worry about trying to find somewhere to go do it. You don't have to, go out and try to make these types of connections in your local community, because right now you can do it at your house. Another one there is that Discover Engineering. These are some cool little projects. You could do them yourself. You can maybe do them with a younger sibling in some cases. Good way to kind of help instill a love of STEM for some younger folks as well. So these might be a fun way to pass the time while you're spending more time at home with friends and family. And now we want to cover just a few minutes about each of our institutions, and then we're going to do a quick question and answer session for you. So Evan is up first.
Fantastic. Thanks, Will. So like I said, I'm from the University of Illinois, Urbana-Champaign. For just a quick point of reference, that's about 2.5 hours south of Chicago in East Central Illinois. People never know where Urbana-Champaign is. It's about 2.5 hour drive down from Chicago. So we have over 150 academic programs at the University of Illinois, lots of options in STEM and outside STEM. We have quite a large student enrollment. We have around 34,000 undergraduates. With our grad students, we total to over 50,000. However, we are able to boast a 19-to-1 student to faculty ratio to make sure that our students can get that personalized access, whether it's through office hours or just meeting with a professor after class. We have a research park, a resource, which are basically 160 plus now on-campus companies where students can work on those research skills, work for these companies for part-time wages, and work on their own startup. So if you want to start developing some of those experiences we talked about in the presentation so far, we receive more than $600 million in funding each year. So plenty of funding to do research. If you want to come here, we are a Research One institution, meaning you can do research in any single field of study here at Illinois. And because of that, we find that about 7 in every 10 students does participate in research, whether it's with a professor within their college or on their own. Those opportunities are all there. We're part of the Big Ten Conference, which is a mainly Midwest-centered conference. It's D1, meaning that those students are playing at the highest level there. Some great athletics to watch here, whether it is your traditional football and basketball or other stuff like the volleyball team. They finished top 4 in the country a couple of years ago. Some of our most notable programs relating to kind of what we've talked about so far is our Granger College of Engineering that houses all of our engineering majors that I've talked about. Several nationally ranked programs in there that students are consistently interested in, such as computer science. We have our Geese College of Business, which has some great programs as well. We have a lot of faculty there who has retired from the field and is now teaching. So they always have great hands-on experience that's the students find super familiar and valuable. We have these computer science plus majors, which I always think are really awesome to talk about. For example, we have computer science plus linguistics. So it's for students who know they want to study computer science and might have a little bit more focused vision of what they want to do with that. With computer science plus linguistics, those students are going to work on with software like Alexa and Siri. So I think that's a cool opportunity that always gives students like oh, okay, that's what that means. We do offer a College of Law at the graduate level, as well as vet and med schools at the graduate level. So if you want to come for that second or third degree, you can definitely come to Illinois for those as well. And then lastly, we have over 5,000 companies that consistently recruit on our campus. Our students are highly recruited based off the opportunities they see here. And we do have one of the largest library systems in the United States with an outstanding Ranger College of Engineering library.
So another one of the orange screens for you to look at, University of Florida. We are another large public university. We are located in North Central Florida. And as of, I think, 2.5 weeks ago, we are now number 6 in the nation for best public university. Really cool, super exciting about that. We are another big school, about 55,000 total students on campus. We have 300 majors, undergrad and grad. We have 15 engineering majors. Okay, none of those are impacted. It doesn't matter to us what you want to study when you apply. We're basically residency and major blind. So no matter what, if you do mechanical engineering, there's nothing additional. You come to campus, they say, what do you want to study? And they say mechanical engineering, you get right in your classes, no big deal. We have over 1,000 clubs and activities, over 2,700 intramural sports teams. We want you doing things besides sitting in the classroom. It's college, go make a new friend, go enjoy yourself a little bit. You can study abroad. We have Greek life. We have ROTC, especially with engineering. Oh my gosh, the military loves engineers. So college is expensive. If you're looking at a way to help offset that cost, Army, Navy, Air Force, Marines, talk to your ROTC person and see if that's an option for you. NCAA D1, just like Illinois, we're the member of the SEC, so we think the Big Ten, SEC laughs at the Big Ten, and the Big Ten laughs at us, and that's okay, we're all still friends. You have undergraduate research opportunities. We spent over $900 million last year on research. We have some product development history on our campus. Many of you know there's this little sports drink out there. Remember, we were the Florida Gators, that little sports drink. Yeah, Gatorade came from our campus, but a long time ago, way back in 1965. We have accelerated medical and dental programs. If you're interested in that, we have a medical school, dental school, vet school, law school, and school of pharmacy, all right there on our campus. We have a 97% freshman retention rate. We're super proud of this, one of the highest in the nation. Our Innovation Academy is if you're into entrepreneurship, product development. So that'd be something that if you're thinking about engineering, you may want to check out somebody's entrepreneur schools. We all have things like that. And one of the things we're trying to do, we just found out, so we're trying to break into the top 5 for best public university. We're not just sitting back on our laurels waiting for it to happen. We are moving forward with artificial intelligence. So when we flip the switch on this new computer we have at like January, will be the fastest and best AI computer of any college or university in the United States. We're also hiring 100 more faculty members to teach AI, and it's still in development. But what they're saying is that no matter what major you are on campus, and especially engineering, if you want to get that artificial intelligence, that AI background, you'll be able to take those courses. So you'll be ready to move right forward when you graduate and have that background ready to go. So that was a little bit about UF. Will, let's hear from another Illinois school.
Awesome. Yes, and a different color there for you. So Illinois Tech is quite different from the last 2 institutions. We are much smaller, only about 3,000 undergraduate students, so much, much smaller. And then just about 4,000 grad and PhD level students. So still about 7,000 total. We are in Chicago, just a few minutes from the immediate downtown core of the city. So our students definitely take advantage of the train system in Chicago and are in the city all the time. We have about 40 different majors that students can choose from. That includes 10 different types of engineering. all of the engineering programs you heard tonight, we have those, plus more. So definitely a great fit for students who might be considering engineering and looking for a more small environment. Definitely something to check out. In addition to that, we do have some of those pre-health programs like Pam and Evan both mentioned, definitely something that you can do at Illinois Tech. One of the things that we really like to do at our university is have a very strong focus on hands-on learning. We do that through a program called iPro, which is a year-long problem-solving course that all of our students take over the course of their time at Illinois Tech, as well as Elevate, which is all about getting you off campus. Internships, co-ops, study abroad experiences, that's all coordinated through our Elevate office at the university. We are test optional this year for admissions for any seniors who are in the room. Free application, and I'm happy to report we are awarding every single admitted student with at least $25,000 in scholarship support as part of our COVID response sort of plan. So definitely a great institution if you are considering engineering and looking for maybe a nice scholarship offer as well. But next up, I know we have some questions that have been coming in. So we're going to have this slide here with all of our contact information. We are more than happy to talk with you about our institutions, and probably if you just have engineering questions or STEM questions, all of us can be a quick resource or find somebody at our university that might be a good resource for you as well. But I know that we have some questions. B, are you going to jump back on and do questions with us?
Yes, sir. Okay. So
Awesome.
first question for our group is what type of engineering is roller coaster building?
That's a great question. I think, Evan, would that probably fall within mechanical engineering that you were talking about a little bit? Pam, any guesses?
My guess is mechanical, but that's my guess.
So what I can do, and this question was from one of our participants, I'm going to actually provide a little link to a resource as well that we can provide there, and that's for you, Nick. But yeah, mechanical sounds about right, Pam. I think also probably structural and electrical. It's going to be like
all of them.
The full kit and caboodle. Yeah. So take a look at that resource, Nick, but I think it's going to be a combination of all of those things. You're going to want expertise in different types to specialize in roller coaster building, which is super cool if you want to do that. Okay. Next question for whoever wants to answer is biomechanical engineering a field job or a desk all the time kind of a job? Any takers?
I'll jump on that one since I talked about it. Almost with all these engineerings, there's not very many that actually sit at the desk all the time. You're going to be using your hands, you're going to be in labs, you're going to be creating, you're going to be designing things. So I guess some aspects of the job, you'd be sitting down and you'd be doing research and reading and maybe designing things on a computer. But a lot of the time you're going to be in a lab working and creating and designing and trying prototypes. So it could probably be, I'd say my guess would be about 50-50 of both, if anybody else wants to jump in on that.
I think you got that about right, if I had to take a guess.
Yeah, and for our participant who asked that question, I provided a resource for you as well. And please do not forget to check out the resources that Will shared with you in the chat box, because those will give you access to a lot of different ways to also explore additional engineering fields, right, and different disciplines within engineering. Because I know that one of the questions or comments about this presentation was, we didn't cover every single type of engineering, but there are so many different types out there, right? So this was, intended to give kind of an overview of some of the types of engineering out there. Definitely other disciplines within engineering. So please use those resources. And again, if you're a student at CUSD, schedule an appointment with one of your college and career counselors, and we can go over more specific questions, more niche fields with you during that session, 100%. But please take advantage of that. And again, use the resources that Will shared with you as well. Do we have any other questions for our presenters as it pertains to their institutions, to preparing to be an engineering student? And again, for the more specific questions about different types of engineering, definitely use your resources that we sent out, and schedule an appointment with one of our college and career counselors as well, because we can definitely get into the nitty gritty of the different types for sure.
So I do have something, and as long as my colleagues are fine with sharing it, I know it is an Illinois resource, but I kind of wanted to share and bring up as we do offer a tool, and I think all of us, all three of our institutions are going to have a lot of opportunities for you to look into these these STEM fields. But Illinois actually offers a tool that I'd be happy to share with you all in the chat that basically allows you to see a good idea of, I'm interested in mechanical engineering. What are fields that I can go into based off of this degree? And then you can do chemical engineering, you can do computer science, you can do whatever that might be, even if it's not something we talked about today. But if you are thinking a major, but you're just not exactly sure what that next step looks like post-graduation, I'd be happy to drop that link in the chat for you all to check that out, because I'm sure all of our institutions will offer opportunities for you similar to what this program Explorer shows.
That would be great. Thank you so much, Evan. Definitely sounds like a useful tool to use. And for those of you who are interested in just additional engineering programs, right, this is where your college search is going to really start to, I guess, blossom, right? And definitely start with something. Thank you, Evan, for the resource in the chat box. Start with something like Big Future on College Board if we want to look at engineering programs across the board, right? So we have some great representation today of schools in Florida and Illinois, and we definitely want you to consider, everything that's out there, especially programs that are not impacted in engineering. Those are very valuable programs to look into, because what does impacted mean, right? It means that there are more qualified students that are applying that can be admitted to the school, which makes it incredibly competitive, right? And those are going to be a lot of the schools that we see just across the board, a lot of the schools in California. But for those of you who are looking for programs in California or outside of California, I would start with something like Big Future, which is through College Board, which is where you can start a more targeted college search. And again, if you want a walkthrough on how to make kind of a detailed plan for yourself, you can schedule an appointment with one of our college and career counselors to talk about that in more depth. I'm going to share another resource with everybody in the chat box on exploring STEM careers through the Bureau of Labor Statistics. What better place to go than, the Bureau of Labor Statistics, which sounds boring, but this is actually geared for everybody in high school if you want to use that as a resource to look into the different fields within engineering.
I'll give you a hint. I used that as part of my research for this project, for this presentation as
Yeah,
well. That's where I got the information about salaries. So that's one of the great things with the BLS is you can look and if salary is a big part of the decision, that can help you and see what some of those pathways are.
Absolutely, absolutely. It is the place to go, right? But yeah, that resource I just shared with everybody in the chat for through BLS will help you actually explore for whoever asked about chemical engineering, computer science, all of that stuff. This is going to be a great resource for you to start. This is where I direct all of my students as we begin the conversation about the different types of STEM careers out there and the different types of engineering that are out there, right? And as far as what schools in California there might be, I would start with Big Future. And if you have questions, you're welcome to email our team at Futureology as well if you have specific questions about that. But what other questions do we have? We have a few more minutes to definitely take some Q&A. So if you do have some other questions, you're welcome to ask them at this time. Obviously, if you don't have any questions, you're welcome to leave for the evening. And we so thank you for joining us. And we thank Will, Pam, and Evan for presenting tonight for our breakout session. We really appreciate your time. But yeah, for our participants, if you don't have any other questions, you're welcome to leave. And if you do, then please, by all means, pop it in the chat box or excuse me, in the Q&A. Okay, I don't see any Q&A coming through. We'll hang out for just a little bit longer, just in case anybody has any questions they might want to ask in a minute.